Hi everyone, in this last video we're going to take a look at how to use some double and half angle formulas to solve some equations. So just like in simplifying and in verifying, we needed to make sure that all of our equations have the same coefficient. All of our expressions, all of our terms have all the same coefficients. So the first thing we want to do is take this 2x and we want to turn it into a 1x. To do so, we're going to use a double angle formula. So we're going to turn 2 sine x into we're going to turn sine 2x into 2 sine x times cosine x. The rest of the equation is going to come unchanged. Now, let's simplify this thing a little bit. Now we've got 2 sine squared times cosine equals cosine. Now, let's go ahead and subtract cosine from both sides. And we now have 2 sine squared x cosine x minus cosine x equals 0. Why did I subtract from both sides? That way, if I can factor something, I can in turn set my factors equal to 0, which I absolutely can factor this thing, right? And now I can set my factors equal to 0. I can say cosine x equals 0 and 2 sine squared minus 1 equals 0, in which case I'll add 1, divide by 2, then take the square root. Don't forget your plus minus. And now we go from our unit circle, we get our solutions. So let's go ahead and write all of them. Pi over 4, pi over 2, 3 pi over 4, 5 pi over 4, 3 pi over 2, and 7 pi over 4. I like to write them all in ascending order whenever possible. All right. And so all of these angles are solutions to the original equation. Class, we will plug in, verify, graph to check your answers, and all that kind of stuff. Lots of different variations. Now, let's do one more. And in this particular case, as you can see, we're going to need to change this 2x. No, not a 2x. We're going to change this x over 2 into an x by using a half angle formula substitution. So let's go ahead and take sine of x over 2 out and replace it with the half angle formula, 1 minus cosine x over 2. And what's nice about that substitution is it simultaneously takes care of unifying the variables in that they're all just x's now, but now they're also all just cosines. So let's square both sides to get rid of this. Let's get rid of this square root. So we now get cosine squared equals the square also takes care of the plus minus, because if it were positive and if it were negative, it would become a positive. But remember that because we're squaring, we are going to need to check for extraneous when we're done. All right, so we now have 1 minus cosine x over 2. I'm going to multiply both sides by 2. Realize that we're dealing with a quadratic, so we're going to bring everything to one side so that we can factor. we've got 2 cosine x minus 1 times cosine x plus 1. We're going to take our 2 factors, set them equal to 0. And we're going to say cosine x plus 1 equals 0, so cosine x equals -1. X equals pi. And so here's the problem. Not the problem, but these are valid solutions. This one is going to be extraneous. Just remember how to check for extraneous solutions. But in general, what we can do is plug into the original equation. So we started off cosine x equals sine x over 2. Let's plug pi in. Cosine of pi is -1. Sine of pi over 2 is +1. Those are not equal to each other. That's why it's extraneous. Remember back here we squared both sides. That would have made this thing true, even though it's false. And that's the introduction of the extraneous solution and why we need to check for them when squaring. So shoot me any messages with any questions you might have, but in this particular instance, these are our 2 valid solutions. I'll talk to you soon, and I'll see you.